Welcome to section 4.6. As I said in 4.5's video, this is going to be overall a review section as we go through. We're going to be dealing with the same type of items that we did in 4.5, but we're introducing something called an imaginary number. So I want to start with some definitions as we go through. First one, the imaginary unit I. Okay, I is the same thing as the square root of -1. Now, we've never been allowed to square root anything that's negative. And what I want you to do real quick is take your calculator and try and square root any negative you know. What will come up on your calculator is something that says error, non-real solution. Your calculator is programmed to only give you real answers. And so this is our way to get around what your calculator can't do. And we call it I, an imaginary number. Well, if I square this I, so I have the square root of -1 and I square it, the squared will cancel with the square root and you end up getting -1. This is probably the most important thing that you need to remember for this lesson because we're going to be using I squared round and around today as we go through, okay? A complex number is a way for us to write things with i's, and it looks like this. A plus bi. Okay, A and B are real numbers, and I is called the imaginary number. Okay, or I'm going to say imaginary part, actually. My pen's not working. Okay, in standard form, A plus bi, A is what we call the real part, and we just said bi is what we call the imaginary part. Oh my goodness, let's try again. Doesn't seem to like my A's, I apologize. Okay, take a look. If you only have a bi, all of this is saying if you only have a bi, then what happens is we call it a pure imaginary part. I might have to see if I can make this work. A pure imaginary part. Okay, so let's keep going. If R is negative, okay, so if R is negative, then the square root of this R, this negative R, what we say is we break this down to look like this. The square root of -1 times the square root of R. And the -1 then becomes the I, and then we leave the square root of R. So same thing, if I look at this with -5, I'm going to break this apart to the square root of -1 and the square root of 5. The square root of -1 is what we call I, and then you still have the square root of 5 left that we can't break down. If you can break it down, then we expect that you would, like you did in section 4.5, okay? If I have I square roots of R squared, this squared is going to get distributed to both, so I end up having I squared and then this square root of R squared. So I squared is -1. The square root cancels with a squared, which is R, so really it's -R. Okay, and this is a little bit of algebra. We're just kind of moving it around as we go. Let me show you realistically how you're going to use this -1 or this I, okay? What I'm going to do is solve an equation like in number 1. To get rid of this squared, we square root. Now, when you square root an answer, go back to yesterday, you get a plus and a minus. Now, I'm going to break this up, and I have the square root of -1, so I take the negative out. And then I want to break down the square root of 12 if I can. Well, I can because 12 is the square root of 4 times the square root of 3. Well, the square root of -1 is I, the square root of 4 is 2, and the square root of 3 I can't do anything with. So I've got this, and I'm going to write this in the best way I can. 2I, we treat it kind of like a variable, 2I with a square root of 3. Okay, so we're basically doing yesterday's work, but when we have a negative underneath the square root, we put an I in our answer. So let's try another one. I'm going to subtract 15 on both sides. So 2x squared equals -50. when I divide by 2, x squared equals negative 25. And I square root both sides. So I get plus or minus, and I'm going to break apart my square root. The square root of negative 1 and the square root of 25. Well, the square root of 25 is just 5, and the square root of negative 1 is just I. So I have plus or minus 5i. Okay? I still get 2 answers because I'm dealing with x squared. In this case, though, I'm just looking at it a little differently because I'm adding an I into the answer. So let's give you a couple of other operations. We're going to treat I in this next section as if it were a variable. And what we're going to do is add like terms, subtract like terms, multiply with FOIL, things like that. So here's what I'm going to do. I'm going to add like terms here. I have a 12 and a negative 8. And 12 plus negative 8 is 4. I have a negative 11i and a positive 3i, which ends up being a negative 8i, and that's my answer. So when you're adding like terms, you're treating I as if it were an x. In the second one, I want to subtract. Now I'm going to rewrite this, so minus 9i, and then I'm going to distribute this negative to both. So minus 24, and a negative make a positive 9i. Okay? Now let's combine like terms. 15 and negative 24, so 15 minus 24 is negative 9. Negative 9i and positive 9i just cancel, so I'm done. My answer is negative 9. Same type of thing in number 3. I'm going to rewrite this. 35, and I'm going to distribute this negative, so minus 13 minus 4i. I'm going to combine my like terms. 35 minus 13 is 22, and then I have this minus 4i at the end, and then you're done. Now, as you're writing these, you always write your answer for the I part second. Okay, that's what's called complex number form. Let's keep going. In number 4, I take this negative 5i and I distribute it to both. So negative 5i times 8 is negative 40 with an I. Negative 5i and negative 9i is a positive 45i squared. Now, I'm going to change colors a minute because here's what we got to talk about. I squared was a definition. I squared equals negative 1. So what this is saying is I have a negative 40i plus 45 times negative 1. Well, 45 times negative 1 is negative 45 minus 40i. And you'll notice I changed the order because my I part has to come second. Okay, one more, we're going to FOIL. I'm going to FOIL this, so first times first. So negative 8 times 4 is negative 32. Negative 8 times negative 7i is a positive 56i. 2i times 4 is a positive 8i. 2i times negative 7i is negative 14i squared. Now before I do anything, I'm going to change this I squared to be negative 1. So I have, and now I'm going to write it over again. You might not need to, but I'm going to. So negative 32 plus 56i plus 8i plus 14, because I have a negative 14 and a negative 1, which turns it to positive. Now I'm going to combine my like terms. Negative 32 and positive 14 makes negative 18. (56) plus 8i, 56i plus 8i is plus 64i. And you're all done. That's supposed to be a 6. Okay? So as you're going through, when they ask you to work with complex numbers, you're just combining like terms as if it were an x. So let's move on. Let's go to the other side. So flip it to the back. And actually, we're going to just do one of these. We skipped these in section 4-5, so we're going to skip number 3 and number 4 also in this section as well. Now, we said if you had a single square root in section 4-5 that you multiply top and bottom by the square root. Same thing with I. If you have an I term in the denominator, you're going to multiply by I on top and bottom. So this is what we need. The rest of this you can get rid of. So I want to show you an example. 2 divided by 3i. I don't care about the 3 on the bottom right now. What I care about is the I. So I'm going to multiply top and bottom by just a single I. And I'll probably put in one more question for you just to make sure. 2 times I on top is 2i. 3i times an I on bottom is 3i squared. Well, I squared is the same thing as -1. So on the top I have 2i. In the denominator I have 3 times -1, which is -3. Done. Now, what could it be worse? You could have to reduce your fraction, but in this case you don't have to. You will sometimes see me write it as -2/3 with an I. These are equivalent. You know me, I like to put my negative on top. And the I part doesn't matter if it's on top or right next to it. It just can't go on the bottom. Okay? So let's try one more. Let's do this. 4 over, let's do it this way, 9i. Okay? If I've got the I on the bottom, I multiply top and bottom by I. You can multiply by 9, but you have to reduce it later, so I just try to avoid it. So in my numerator, I have a 4i. In my denominator, I have 9i squared, which just means I have a -9 in my denominator. So I have -4/9 with an I, or -4i over 9, or 4i over -9. 3 ways to write the same answer. Okay? So that's the idea of dividing. You just don't want an I in the denominator like you don't want a square root in the denominator. Okay, last part. Let me move this out of the way. We're talking about complex numbers on a graph. Okay, and we're going to do 2 different things. We're going to graph it, and then we're going to talk about its distance on a graph, and I'll show you both. Here's what happens. In this, you have a real axis, which is our x-axis, and then you have an imaginary axis, which is our y-axis. The real axis goes up by 1, 2, 3, 4, like it normally does. The imaginary axis goes up by 1i, 2i, 3i, 4i. So you count i's. You plot points the same way you did as when they were a coordinate. If I have in number A, 4 plus 2i, that means I go right 4 and up 2i. There's my point for A. In B, -1 plus 3i means I go left 1 and up 3i, and then I get my B. C is just 3, so I go over to 3. I'm not going up or down any i's, so there's my C. D is -4i, which means I just go down 4 i's. There's my D. And last one, E. -2 means left 2, minus 2i. There's my E. Okay? So as you're going through, when we ask you to graph imaginary numbers or complex numbers, it's actually really, really easy. Just label your y-axis with i's instead of just single numbers. Last part talks about a distance, and they tell you that is an absolute value, and all that means it's the distance between the origin and your complex number. Okay? So here's what I want to do first. Take a look and plot the point 4 plus 2i. So I go over 4 and up 2i, and I plot my point. The question is, from the origin to that point, what is that distance, and we call that the absolute value of our complex number. In order to find the distance, we're basically going to use the distance formula, or I'm going to change this a minute. We're going to actually end up doing this. We're going to make this triangle. If you can kind of see a triangle now, and we're going to have a right angle, and we're going to use Pythagorean theorem. Okay, so here's how it works. The distance from here over is 1, 2, 3, 4. So this has a distance of 4, and up has a distance of 2. So we end up saying 4 squared plus 2 squared equals our z squared, or whatever you want to call it, equals the hypotenuse squared. I'm going to call it h a second, hypotenuse squared, and we square root. 4 squared is 16, plus 2 squared is 4, so I have the square root of 20, and I can break that down into 5 and 4. The square root of 4 is 2, so my absolute value for the z, which we denote absolute value of z, is 2 square roots of 5. And that's what this formula says. It's actually Pythagorean theorem. Okay, so let's do one more. I'm going to switch my color so we can kind of see this. As we're going through, negative 4i is down here. And the question is, what's this distance here? I'm going to write it as 0 minus 4i, and then I'm going to take you in terms of the formula. I take the square root of 0 squared plus negative 4 squared. I never care about the I, because the I changes a value. We're not changing a value, we're looking for a distance. This is 1, 2, 3, 4. Well, 0 squared is 0. Negative 4 squared is 16, so the square root of 16 is just 4. And as you look at this, can't you count? The distance from here to here is 1, 2, 3, 4. All right? But this is the idea. We're asking you distances when they talk about an absolute value. So that's it for section 4.6. We've introduced this idea of an imaginary number, and we're going to work with that from sections here on out so that you get more comfortable with this letter that we use, I.